Hello, welcome to another lesson. In this lesson, we'll be considering Python for cybersecurity. Python is the #1 programming language used by security professionals worldwide. So we are going to learn why Python dominates security workflow, explore common use cases, compare Python versus Bash, and discover the essential libraries every security professional should know. So let's dive in. Why cybersecurity professionals use Python? Python is the #1 programming language for cybersecurity professionals. It is not just an opinion, it is a fact. You can walk into any security operations center or penetration testing team and you are going to find out that Python is everywhere. Now let's consider some of the key reasons why Python dominates. First, it is easy to learn and read. The syntax is beginner friendly and almost like writing English, but don't let that fool you. Second, it is powerful for advanced tasks with professional grade capabilities. Third, there are extensive security-focused libraries built specifically for hacking and defense. Fourth, it is cross-platform, that is, it runs on Windows, Linux, and macOS without modification. Fifth, it encourages rapid development and prototyping, and this means you can write tools in minutes instead of hours. And finally, it is the industry standard for automation across security teams globally. Who uses Python in security? Number 1, penetration testers that write custom exploits and automation scripts. Number 2, security analysts that process logs and detect threats. Number 3, malware researchers that reverse engineer and analyze malicious code. Number 4, SOC teams that automate incident response workflows. Number 5, red team and blue team operators that build attack and defense tools. And number 6, security automation engineers that create frameworks that other teams use. If you want a career in cybersecurity and you are open to learn Python, I will tell you that Python is not optional. It is essential. Let's now see where Python fits in real security operations. Python touches every phase of security work, and I'm going to show you how. The first phase is reconnaissance and scanning. In reconnaissance and scanning, Python automates nmap scans and parses the results. It performs subdomain enumeration to map attack surfaces, it handles scanning and banner grabbing to identify services, and it gathers OSINT, that is open source intelligence, from public sources. The second one is vulnerability assessment. And for vulnerability assessment, Python builds custom vulnerability scanners tailored to specific environments. It parses and analyzes scan reports from tools like Nessus and OpenVAS, and it correlates vulnerabilities across systems to find patterns. And to the third one, exploitation and post-exploitation. In exploitation and post-exploitation, Python develops custom exploits when Metasploit doesn't have one. It generates and encodes payloads to evade detection. It automates Metasploit workflows so that you don't repeat the same steps manually. And it creates data exfiltration scripts to steal information from compromised systems. And to the last one, incident response. For incident response, Python analyzes and correlates logs from thousands of events. It automates threat hunting to find attackers hiding in networks. It extracts forensic data from disk images and memory dumps, and it checks for IOCs, that is indicators of compromise, across entire networks. Python is the glue that connects all security tools and makes workflows efficient. Let's look at common automation tasks security professionals do with Python every day. The first one we'll consider is network security. For network security, Python automates port scanning across multiple targets instead of scanning one at a time. It analyzes network traffic and inspects packets for malicious activity. It validates firewall rules to ensure configurations are correct, and it checks SSL and TLS certificates for expiration and weak encryption. The second one is web application security. In web application security, Python creates custom web scrapers for reconnaissance. It tests and fuzzies APIs to find vulnerabilities. It builds SQL injection testing scripts tailored to specific applications, and it generates XSS payloads with different encoding to bypass filters. The third one is password and hash operations. For password and hash operations, Python automates password cracking with tools like Hashcat. It identifies hash types automatically so that you know which algorithm to crack. It generates and manipulates word lists for brute forcing, and it creates credential stuffing attack scripts that test leaked passwords across multiple sites. Then to the last one, which is report generation. For report generation, Python passes output from Nmap, Nessus, Bobsuite, and OWASP-Zap. It generates executive summaries that non-technical stakeholders can understand. It creates vulnerability matrices showing risk across systems. And it automates clients' deliverables so that reports are consistent and professional. These aren't theoretical. These are tasks penetration testers and security analysts do daily. Here is a common question. When should you use Python versus Bash? Don't get me wrong, both are valuable, but they have different strengths. Now, you can use Python when you need complex data structures like lists, dictionaries, and objects. Use Python when working with APIs and JSON or XML data. Use Python when you need cross-platform compatibility so that your tool works on Windows, Linux, and Mac without changes. Use Python when building reusable tools and frameworks that other people will use. Use Python when parsing complex file formats like CSV, XML, or binary data. And use Python when working with encryption and hashing operations. Lastly, use Python when you need extensive error handling for robust tools. This is when you should use Bash. Use Bash when doing simple Linux system administration tasks. Use Bash when chaining existing command line tools together with pipes. Use Bash for quick one-liners for file operations that take 2 seconds to write. Use Bash when working exclusively on Linux or Unix systems. Use Bash for simple text processing with grep, org, or sed. And use Bash when running system commands in sequence where you don't need complex logic. And what's the best practice? Use both together. Use Bash for system-level tasks and quick automation, and use Python for logic, parsing, and complexity. Real security professionals know when to grab Bash and when to write Python. You often use Bash for calling Python scripts or Python to execute Bash commands. Now let's explore essential Python libraries for security. The first one we'll consider is Scapy. And what is Scapy? Scapy is a powerful packet manipulation library. It lets you create, send, sniff, and analyze network packets at a low level. And with Scapy, you can build custom network tools from scratch. Also, you have full control at any OSI layer with no limitations. Now, here are the common uses of Scapy. This includes custom network scanners that work differently from Nmap, ARP spoofing, and man-in-the-middle attacks to intercept traffic, packet sniffing and analysis to understand network behavior, network protocol fuzzing to find vulnerabilities in implementations, and custom ping and trace routes tools with special behaviors. Now, why is Scapy powerful? It is powerful because you have full control over packet construction. There's no need for separate tools like HPing3 or networks. Everything is programmable network interaction in pure Python code. Scapy is the Swiss Army knife of network security testing. The next library we'll consider is Requests. So what is Requests? Requests is a simple HTTP library for Python. It makes API calls and web requests incredibly easy. And it is essential for web application testing because it handles cookies, sessions, and authentication automatically. SSL or TLS certificate verification is built in. It also has proxy support for routing through burp or zap, and it has custom headers and user agent spoofing. Let's now consider the security use cases. Security use cases are everywhere, including automated web reconnaissance to map websites, API endpoint enumeration to find hidden functionality, testing authentication mechanisms for bypass vulnerabilities, and session management testing to identify session fixation or hijacking, CSRF token extraction for cross-site request forgery testing, credential validation to check if accounts are valid, and web scraping for OSINT gathering. Why do pen testers love requests? They love it because it is simpler than Python built-in URL lib. The code is clean and readable even for beginners, and it integrates perfectly with other security tools in your workflow. If you test web applications, you are going to use requests constantly. The next one we'll consider is BeautifulSoup. What is BeautifulSoup? BeautifulSoup is an HTML and XML parsing library. It extracts data from web pages reliably, and it works perfectly with the requests library we just discussed. It also navigates the DOM tree to find any element. Now to the security applications. These include scraping employee names and emails from company sites, finding hidden form fields and input parameters, discovering API endpoints that are buried in JavaScript, extracting version numbers from different error pages, and parsing security tool HTML reports automatically. And the common workflow is simple. First, use requests to fetch the web page. Second, use BeautifulSoup to parse the HTML. And third, extract what you need, such as links, forms, comments, or metadata. And here is an example use case. You can scrape employee names from company websites for social engineering, find email addresses and subdomains for attack surface mapping, extract version numbers from error pages that review software versions, and parse security tool outputs when they generate HTML reports. BeautifulSoup turns messy HTML into clean and usable data. Now let's talk about cryptography libraries for security work. The first one we'll consider is HashLib. HashLib is built into Python. It provides MD5, SHA-1, SHA-256, and SHA-512 hashing. You can use it for password hash generation, file integrity checking, and hash cracking scripts. The second one is the cryptography library. The cryptography library handles symmetric encryption with AES and FireNet. It does asymmetric encryption with RSA for public key cryptography. It handles digital signatures for authentication, and it manages certificate handling for TLS and SSL operation. Then the last one here is PyCrypto, and this is now replaced by PyCryptoDome. This is a legacy encryption library. It is still used in many existing security tools, and it provides AES, DES, and RSA implementations. Here are some security use cases. Security use cases are critical, and some of them are password cracking and hash analysis to recover plain text passwords, encrypting exfiltrated data so that it is not detected by data loss prevention systems, decrypting captured credentials from network traffic or databases, and creating custom encryption tools for specific needs. Another one I can add is SSL and TLS testing to find weak ciphers and configurations. So understanding cryptography is essential for both attacking and defending systems. Another powerful library we'll consider is Paramiko. What is Paramiko? Paramiko is an SSH client library for Python. It automates SSH connection and command execution. It has SFTP file transfer support built in. It executes commands and capture output programmatically, and there is no need for manual termination interaction. Let's now consider the security applications. These include automated SSH brute forcing to test weak credentials, post-exploitation command execution once you have credentials, lateral movement automation to spread across networks after initial compromise, remote file retrieval to exfiltrate data over SSH, and SSH key testing to validate key-based authentication, and lastly, multi-host command execution for managing compromised systems. Paramiko is common in post-exploitation frameworks like Empire and Covenant. It is an automated penetration testing tools. It is essential for red team operations across large networks, and it is used in configuration auditing to check SSH settings across hundreds of servers. Let's quickly cover more essential libraries we are going to encounter. The first one is Socket. Socket is built into Python. It provides raw network programming capabilities. You use it for custom port scanners, creating reverse shells and bind shells, and testing network services at a low level. The next one is Subprocess. Subprocess is also built in. It executes system commands from Python. You can use it to integrate Nmap, SQL map, and other tools, and you can capture command output for parsing in your script with it. The next one is regular expression, which we call regex. RE or regex provides regular expressions for pattern matching in logs and outputs. You can use it for extracting IPs, emails, and hashes from text, and it is used for parsing complex text data with patterns. The next one is Impacket. Impacket provides network protocol implementations for Windows environments. It handles SMB, Kerberos, and LDAP attacks, and it is essential for Windows authentication testing and Active Directory exploitation. The last one we'll consider is the pawn tools. Tools is an exploit development framework. It is used for buffer overflow exploitation and binary analysis. It generates and injects shellcode into vulnerable programs, and it is used for process interaction and memory manipulation. Each library solves specific security problems efficiently. Here are some of the key takeaways from this lesson. Number 1. Python is the number one language for cybersecurity. It is easy to learn and powerful to use. Number 2, Scapy gives full packet level control because it can be used to build any network tool you need. Number 3, Request handles all web and API interaction for web application testing. Number 4, BeautifulSoup parses HTML for reconnaissance, OSINT and report extraction. Number 5, HashLib and cryptography cover all encryption, hashing, and password operations. Number 6, Paramiko automates SSH. It is essential for post-exploitation and lateral movement. Number 7, socket, subprocess, RA, regex or regular expression, imperfect, and pawn tools are core toolkits that uses Python. And lastly, use Python for complexity. Also, use Bash for quick system level chaining. That's all for this lesson, and before we go, here is a challenge question for you. The question is, what is the difference between using Python versus Bash for security tasks? I come again. What is the difference between using Python versus Bash for security tasks? I'll be waiting to see your answer in the comment section. Thank you so much for staying through and watching this till the end. Also, do not forget to like, share, and comment. And most importantly, subscribe to our YouTube channel because there are more amazing videos that we're going to drop in the future. Thank you and see you in the next lesson.